wabarakatuh. My name is Muhammad Amin bin Hamidun, AE190056. So today I'm going to explain about our group project, which is off-grid photovoltaic system. So this is group 2 members, consists of 4 person, Shafiq, Fikri, Amir, and Hilmi. So I'm gonna explain for abstract part. So we propose approaches for our research that might be used to other off-grid application. We'll use an off-grid residential as an example to demonstrate design technique. The off-grid residential house project will run entirely on solar energy, with solar photovoltaic harvesting electricity to power gadget. Next, the introduction of the project. So the international interests have intensified research and development into sustainable energy system in response to growing worries about global warming and the autonomous solar system that produce electrical power to charge bank of batteries during the day for usage at night when the sunlight is unavailable is known as basic standalone PV system, also known as off-grid photovoltaic system. So this paper will focus on how methodology of off-grid system can help Mr. Ahmad Nisfu to reduce the dependency of grid and allow us to live in self-sufficient manners without reliance on one or more public utilities. So, and then PV system will be designed using PV6 software. So on the left side of the slide, you can see the example of off-grid photovoltaic system. We must have a solar panel, charge control, batteries, inverter, and our load. Next, the problem statement. So during this project, we found a little bit problem. Mr. Ahmad Nisfu, among the problem faced by the house is high usage of energy consumption. Next, total load of electrical appliance for a house is high. And before designing a power generation plant, it requires to consider on the type of energy used. To ensure that suitable solar panels and inverter is fit perfectly, gain and collecting data for the power consumption that the place used per annum is needed. So our main objective of this project is to convince Mr. Ahmad Nisfu about the environmental issues involving photovoltaic system and to calculate the cost of designing this PV model for the construction of Mr. Ahmad Nisfu residential home and to create an off-grid photovoltaic system concept that is renewable energy in order to reduce pollution on our planet. So that's all from me. I will pass to the next presenter.
Hello and good day everyone. My name is Muhammad Shafiq bin Kasmazuli and my matrix number is AE1007. And now I will present to you on the simulation of our project by using the PVC version 6.88. So the first thing to do is we need to determine our orientation first. So in this orientation, we are going to set our degrees of our solar panel, which is plane teeth. So in here, we are set to 30 degrees. Then we click OK. After that, for the user needs, in this user needs, we are going to determine the number of the appliance and also the power of each appliance. And also we are going to calculate the daily use for the appliance. And for the user needs, we are going to calculate the total daily energy for the daily household consumption per year. Then after we determine that, we can finally we get that our total daily energy is 60,624 watt per day. And then we click OK. Then next we are going to set up for our systems. So for our systems, we are going to determine our battery first. So in this project, we are using our lithium ion with 12.8 volt 103 Ah battery module Li-ion since 2017. which is 4 in series and 5 in the module in parallel. So we must make sure that by doing the simulation, our global capacity exists with the suggested capacity, so that the simulation we can run smoothly. And next, we are going to determine our PV array. So for the type of the PV module, we are using the generics, which is 340 WP 20x volts, which it is a C mono, 340 WP twins 100s for cells, and which it is the number of module and string is 4 in series and 4 in strings. So in this simulation, we must make sure that our maximum operating power is exists or close to the enter plan power, so that the simulation can run smoothly. For the backup and simplify, there's nothing to do. Next, after that, we click OK. Then after that, for the detail loss. So in the detail loss, we are going to determine the loss energy when we run the simulation. Then click the OK. Next, for the horizon. So the horizon is the simulation it is automatically calculate the number of sun height when at the certain location that we choose when we are running the projects. Next, click OK. Then for the near shadings. In the shadings, we are going to construct our PV module. So here, this is how to construct the PV module. Click the by module and set our PV array by including based on the PV type number of PV array. So here we are using 16 type of mono 340 WP twin 120 half cells of PV array. So we have a 16 numbers of PV array that we use for our projects. Then after that, click OK. And then for the economic evaluations, in this economic evaluation, we are going to calculate the cost of the appliance that we use for our project, which is support of modules, batteries, and also controller. We also calculate the cost for the maintenance that we need to use for our projects. And then after we calculate the cost, click OK and run the simulation. And after we run the simulation, we will get the reports that show exactly the value and the information of our projects. So here are the reports here. The final report that we'll get after we run the simulation smoothly. So that's all for me. Thank you.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Fikri Haris bin Sbawi. My matrix number is AE10041. Right now I will continue for the explanation about the design and manual calculation. Okay, so in order to design this off-grid photovoltaic, first the thing that we need to find is the load analysis, sizing of solar PV panels, sizing of battery bank, sizing of inverter, and sizing of solar charge controller. Okay, now I will show you. For the first one is the load analysis. This is the thing that we have find, and we put for equipment, power, quantity, total power, duration, and power consumption. As you can see here. Okay, for the sizing of solar PV panels, first we find for the daily consumption, we got 16.9 kilowatt hour. For the sun peak hour is 8 hour, and we multiply, we find for the PV power daily consumption divided with sun peak hours and multiply with 1.3, and we got this. And if you want to find the number of PV panels, this is the formula, and we put the value, and we got like this. It is 16.16, and we assume it's 16 number of PV panels. Okay, number 3, sizing of battery bank. The first one, we need to find the battery bank capacity. The formula is daily consumption divided with DOD time EFF times system voltage, and we put the value, we get this. as you can see here. Find the number of strings, you put the value, we just use this formula, and we got the number of strings is 5. And number series is like this, system voltage divided with VR, and the number of series we got 4. Okay, number 4 is sizing of inverter. First we need to find this thing, and you put in the with each terms, and then we got the minimum inverter power. So we choose inverter with power rated of 4000 watts since it's greater than minimum inverter power. This is the minimum inverter power. Okay, the last one is sizing of solar charge controller. We need to find for number series Vmax over VOC, and this is the value, and the number series is like this. We assume it's 4. The number of string is this, number of PV panels divided with number of string, and we got number of string is 4. And the last one ICC, we put the value in this formula, and we get this ICC is 26.375 ampere. So the last one, we got the designing of the circuit of grid photovoltaic. This is the typical layout of a standalone system. Okay, I will pass to my members to continue. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Hilmi Hazi bin Afami, metric number AE190048. So I would like to explain our discussion for this project. So first is the purpose to install the off-grid photovoltaic system for the residential of Mr. Ahmad Nisfu. So these solar panels have a long lifespan and can last up to 25 years if well maintained. As suggested, we advise to maintain it annually. So Mr. Ahmad Nisfu will be able to save a large amount of money of his monthly electric bill. He also won't have to worry about power disruptions if he's using a off-grid photovoltaic system. So this is the list of solar power system equipment. So we need to use about 16 solar panel, a solar charge controller, a 20 battery, and 1 inverter. Next, this is the cost for the solar installment. So as you can see in this report, so as I can conclude, the installation cost for this photovoltaic system is about 41,900. So the maintenance cost is about RM100 for the annually. So next, I would like to explain about the benefit of applying solar PV for the residential houses. So the solar PV can help in reduce the air pollution and improve humanity's health in the long term. It also can help fight for the climate change. So this reason is because of the PV panels can generate electricity both clean and green. The solar energy also is free. The price is also steep decline, which is give a good benefit for the sustainability in terms of economy and environmental. The solar panel also is minimal operating and maintenance. As we can see, the maintenance is about annually, which is also a bit affordable, which is 100 annually. So that's all from me. Thank you.